Hi, welcome to Chemistry Solutions with Steve. This is an AQA GCSE Chemistry revision on percentage yield and atom economy, and it's for single chemistry science only. From section 4.3, Quantitative Chemistry. Can you remember from a previous topic what a formulation is? A formulation is a mixture that's been designed as a useful product. Now, formulations are made to a complex, exact recipe, a bit like making a cake. And each component or product is measured carefully. And chemists need to get the maximum amount of the desired product. We know atoms are not created or destroyed in a chemical reaction, but it's often not possible to obtain the theoretical calculated yield of a product due to several factors. Stop the video. Can you remember any of these factors? Now, the first one involves reversible reactions, and a reaction just might not go to completion. Secondly, a portion of the product may be lost during its separation, spillage. Some reactants may participate in side reactions, other reactions rather than the one that's intended. All these can prevent 100% yield. A theoretical yield is the highest possible mass of a product from a chemical reaction. It's calculated using balanced equation, using the mass and the relative formula mass of the limiting reactant and the relative formula mass of the product. Pause the video and see if you can remember and write down the formula for percentage yield. So, percentage yield is the mass of the product actually made divided by the maximum theoretical mass of the product times 100. So let's do a basic worked example. Copper oxide reacts with sulfuric acid to make copper sulfate and water. In an experiment, 3.6 grams of dry copper sulfate crystals are made. If the theoretical yield is 5 grams, calculate the percentage yield of copper sulfate. So the actual yield is 3.6, theoretical yield is 5.0. We apply the formula, actual yield divided by theoretical times 100, 3.6 divided by 5 times 100, 72%. Let's try a more typical but challenging example. 25 grams of Fe2O3 iron oxide was reacted and it produced 10 grams of Fe iron. What is the percentage yield? And we've got a balanced equation here. Fe2O3 plus 3CO goes to 2Fe plus 3CO2. So we've got 25 grams of our limiting reactant, Fe2O3, and we've got to work out, firstly, what the mass of iron is produced before we can work out the percentage yield. We need to work out the theoretical mass. So part 1 is going to get us to work out the theoretical mass using moles and our table method. The MR, the formula mass of iron oxide, is 2 times 56 plus 3 times 16. That's 2 irons and 3 oxygens. That comes to 160. So if you've seen my video on reacting masses, you'll know that we use this table method for working out reacting masses, because that is what we're doing today here. So we put the two molecules or atoms at the top, Fe2O3 and Fe. Down the side, mass Mr. moles ratio, and we sub in and then use our formula triangle Mr. moles with the mass on his head. So we've got 25 grams of iron oxide, the MR is 160, Mr. moles with the mass on his head means we have to divide the mass by the Mr, and that gives us 0.1563. We leave that number in our calculator because we're going to need it later on. Take the ratio from the equation, which is 1 to 2, iron oxide to iron. For every 1 iron oxide there's 2 moles of Fe. Then we work our way back up the right hand side. If there's 0.1563 moles of iron oxide, there must be twice that, 2 times 0.1563, which comes to 0.3126. So the Mr for iron is 56. That was the AR that we got upstairs there. And then we use our triangle again to work out the mass, which is the moles times the Mr. That gives us a theoretical mass, if we round it up to 3 sig figs, of 17.5 grams. That's what we should get, 100%. Just jot that down. The maximum theoretical mass of iron is 17.5 grams. From the question, the mass of iron actually made was 10 grams. The percentage yield is the mass of the product actually made divided by the maximum theoretical mass times 100. So that's 10 divided by 17.5 times 100, and that gives us a percentage yield of 57%. Let's take a look at this past paper question. An acid and a base react to form a salt. The maximum theoretical mass of the salt that could be produced using 50 cm cubed of the sulfuric acid is 12.5 grams. The percentage yield of the salt is 92.8%. Calculate the mass of the salt actually produced using the equation percentage yield equals the mass of the salt actually produced divided by the maximum theoretical mass of salt that could be produced times 100. Now this is a challenging question because it is a rearrange the equation. So there's 2 ways to do this. You can either sub in all the numbers and then rearrange, or rearrange and then sub in the numbers. I'm choosing this time to sub in the numbers and then rearrange the equation. So if you look here in yellow, the percentage yield is 92.8%, so I can sub that straight in. And the theoretical mass is 12.5 grams. So as we've subbed in, you can see 92.8 equals the mass of the salt produced times 100 over 12.5. Now we need to do a bit of algebra here, and we need to do a bit of cancelling out. So we multiply both sides by 12.5. Then cancel as so, and we divide both sides by 100 as so, cancelling as we're going along, and we end up with the mass of the salt is 12.5 multiplied by 92.8 divided by 100. So we can crunch that on our calculator and we get an answer of 11.6 grams. So there's a mark for subbing in the numbers, a mark for the final equation and a mark for the final answer. 3 marks. Okay, let's move on to percentage atom economy. And this is about making as much stuff as you can. So chemists, let's look at a reaction. Chemists might look at a reaction like A plus B goes to C plus D. A and B are the reactants. This is what we're using. This is what we're going to use for our recipe. C is our useful desired product. That's the stuff we're trying to make. And D is our byproduct. Often waste, but not always. Sometimes we can use it. But what we're trying to do today is to work out how much of C there is as a percentage of A and B. And we must try and get C as high as possible to save energy and to stop waste. So, in terms of definitions, the atom economy is the measure of the amount of the starting materials that end up as useful products. And as we've said, it's important for sustainable development and for economic reasons to use reactions that have a high atom economy. Now, pause the video and see if you can remember the equation for percentage atom economy. Now, it's a bit long-winded, but we'll shorten it later. Percentage atom economy is the relative formula mass of the product from the equation, so this is the desired product, divided by the sum of the relative formula masses of all reactants, times 100. So, let's do a worked example. Calculate the percentage atom economy for the following reaction where Fe, iron, is the desired product, assuming the reaction goes to completion. And you've got the ARs for Fe, 56, O, 16, C, 12. And you've got an equation, a balanced equation. Fe2O3 plus 3CO goes to 2Fe plus 3CO2. Pause the video and see if you can work out the atom economy for this example. As in the question, we know that iron, Fe, is our desired product. That's what we're trying to make as much of as we can. In green there, those are our reactants. Those are the two things that go together to make the iron. And the CO2, that's the byproduct. So we've got a shortened version of the formula. Percentage atom economy is the MR of the product that we want divided by the MR of all the reactants times 100. Now here's a situation where we could go wrong here. So when we say the MR of the product, what we really mean is the total relative mass. So we have to include the numbers in front, the coefficients, the numbers of moles. So for the MR of the iron, it's 2 times 56. This is a key mistake that people make. The MR for the reactants, that's pretty straightforward. 2 times 56 plus 3 times 16 plus 3 lots of 12 plus 16. Add all that up, 244. So we need to sub in the numbers. The MR of the product divided by the MR of all the reactants. 112 divided by 244 times 100, and that gives you 45.9% for the atom economy for the production of iron. Right, so let's look at a past paper question. Copper oxide reacts with hydrogen to produce copper. The equation for the reaction is CuO plus H2 goes to Cu plus H2O. Calculate the percentage atom economy for obtaining copper from this reaction. The relative atomic mass of copper is 63.5, and the relative formula masses for hydrogen is 2, copper oxide 79.5. Pause the video and have a go. Now, our formula masses and MRs, etc., they're all worked out for us. They've given those in the question. So all we need is the formula, which we know is the percentage atom economy MR of product divided by all MR of all reactants times 100. We know our product is the copper, the Cu. The reactants are the copper oxide and the hydrogen. So subbing in the numbers, we have 63.5 divided by 79.5 plus 2. So we put that into our calculator, we end up with 63.5 divided by 81.5 times 100 for the percent, and to 3 sig figs that gives us 77.9% for the atom economy. So, in terms of marks, we get 1 mark for working out the MRs, we get 1 mark for an equation, 63.5, etc., and a final mark for our final answer. Further question. The fermentation of sugar to make alcohol, ethanol, occurs on an industrial scale. The balanced equation for the reaction is C6H12O6AQ. Glucose goes to 2C2H5OH, that's the ethanol, plus 2CO2. Calculate the atom economy for obtaining ethanol from this reaction. Your answer should treat us 3 significant figures, and you've got the atomic masses for carbon, hydrogen and oxygen. Pause the video. So, we've got to work out, first of all, the MR for the sugar, the glucose. And this is the complicated bits for this one. We're not given the MR. So we've got 6 lots of carbon, so that's 6 times 12. 12 hydrogens, so that's 12 times 1. And 6 oxygens, so that's 6 times 16. Crunch that on your calculator and that comes to 108. So for the MR of ethanol, that's 2 times 12 plus 6 times 1 plus 16. That gives us 46. 2 moles of ethanol, so the relative mass of the useful product is 2 times 46, which gives us 92. So we've got all the numbers we need now to do the atom economy. So atom economy, MR of product over MR reactant times 100. 92 divided by 180 times 100, 51.1% to 3 sig figs. I hope you got something from this and you feel a bit more confident. The usual clicks are at the end of the video, and the playlist has got lots of videos on how to do all the different types of calculations in chemistry. See you next time.